All right, use substitution for trigonomic functions. So, if we were given the function cosine of x dx, that'd be pretty easy to solve. It's just sine of x. But what if we have cosine of 3x? Well, when we're integrating a trig function, or when you're finding the derivative of a trig function with something more than just x in the argument, it becomes a little more complicated. Therefore, when you're doing the integral of that same function, of a function with something in the argument more than just x, it also becomes a little bit complicated. So what we do is we set u equal to 3x in this case, which is the argument. We set u equal to the argument in this case. Now, because u is equal to the argument, this means that we can plug in u for cosine of x, or cosine of 3x. We can plug in u for 3x to get cosine of u. But also we must find the derivative of u, which is just 3 dx, and find du over 3 to equal dx, because we can't have a u here and a dx here. What this means is now we have cosine of u times du over 3. I plugged this in for dx, and I plugged this in for u, this in for the argument. Now, when we find the derivative of this, we get 1/3 times times just sine of u. Plus c. Now we plug our original function back in for 3, or back in for u, 1/3 sine of 3x plus c. Now if we were to find the derivative of this, the sine of 3x would turn to cosine of 3x. We'd multiply it by the derivative of the argument times 3, and that would cancel out the 1/3, so we'd just get cosine of 3x. C would go to 0. Now, a lot of times this can also be used when we're working with problems involving, so let's say, secant times tangent, secant of x times tangent of x, and when this is cubed dx. In this case, what would be a good idea to do is, let's say the secant is squared. So secant squared x times tangent cubed x. In this case, we would let u equal tangent of x. Now, du would equal secant squared x. Move that squared over here to make it clear. Dx. And dx would equal du over secant squared. Now, a lot of times in cases like this secant squared will conveniently cancel out with this secant squared. So when we plug this back in, we'll get secant squared x u cubed du over secant squared x. These two cancel out, and we simply get u cubed du. Now, this is an easy integral to solve now. That is 1/4 u to the 4th plus c, and which is 1/4. We plug in tangent of x to the 4th plus c. Now, finally, sometimes we have to do this with inverse trig functions. And a lot of times what we will be able to notice is a function will look something like the integral of 1 over the root of 1 minus 4x squared dx. Oh no. Ooh, pencil. So, in cases like this, you may notice that this equation looks fairly similar to 1 over the root of 1 minus x squared. And in fact, which is equal to the derivative of sine inverse of x. Now, generally, the only problem is we have a 4x squared instead of just an x squared. What we can do is we can set u equal to 2x. And we can sub in, we can imagine that this is actually equal to the root of 1 over the root of 1 minus 2x squared. Because when we distribute that out, it becomes 4x squared. But now, u is equal to 2x, du is equal to 2 dx, and dx is equal to 2. Or du over 2. Now, what we do is put 1 over 1 minus u squared du over 2. Now, this, since this is the inverse of sine, this is sine inverse of u plus c, and this is all over 2 because of that right there. Now that we have this, all that's left is for us to plug back in the 2x for u. So sine inverse of 2x plus c, we're going to do 1/2. And that's how you do u substitution with trig functions.